Attributes: minus pixel density, minus refresh rates, minus screen resolution, minus color gamut. To round out your knowledge for the A+ and your upcoming labs at BCC, we need to look past the physical screen tech and talk about attributes. If the screen type is the engine of the display, these four attributes, resolution, pixel density, refresh rate, and color gamut, are the performance specs. They determine exactly how sharp, how smooth, and how vibrant your digital world looks. 1. Screen resolution. Screen resolution is the total count of pixels on your display, usually written as width by height. Think of pixels as the microscopic atoms of an image. If you have a standard full HD monitor, you have 1920 pixels across and 1080 pixels down. When you multiply those together, you get roughly 2 million little dots working together to show you the Ubuntu terminal or a packet capture in Wireshark. As a technician, you must understand that every display has a native resolution. This is the exact number of physical pixels built into the glass. If you try to run a lower resolution on a high-end screen, the image will look fuzzy or blurry because the monitor has to stretch the digital pixels across multiple physical ones. For the best clarity, always match your software settings to the monitor's native hardware specs. 2. Pixel density, PPI. While resolution tells you the total number of pixels, pixel density, measured in PPI or pixels per inch, tells you how tightly they are packed together. This is why a smartphone screen looks so much sharper than a massive office television. If you have two screens that are both 4K, but one is a 5-inch phone and the other is an 80-inch TV, the phone has a massive pixel density. The pixels are so tiny and close together that the human eye cannot see the individual dots. In your cybersecurity work, high pixel density is a huge benefit. It allows you to read very small text and see fine details in complex diagrams without the edges looking jagged or pixelated. 3. Refresh rate. The refresh rate, measured in hertz, is the speed limit of your screen. It tells you how many times per second the monitor can completely redraw the image. The industry standard is 60 Hz, meaning the screen refreshes 60 times every single second. This is perfectly fine for typing an email or delivering mail. However, in high-end gaming or for professional workstations, you will see monitors rated at 120 Hz, 144, or even higher. A higher refresh rate makes motion look liquid smooth. When you move your mouse cursor across the screen or scroll through a long log file, there is less ghosting or stuttering. For the A+ exam, remember that to actually see these high speeds, your graphics card must be powerful enough to produce those frames, and your cable, like DisplayPort, must have enough bandwidth to carry them. 4. Color gamut. Finally, we have the color gamut. This represents the total library of colors that a monitor is physically capable of displaying. Not every monitor can show every color that exists in nature. Most standard monitors aim for a gamut called sRGB. It covers the basic colors we see on the web. However, professionals who do photo editing or medical imaging use wider gamuts, like Adobe RGB or DCI-P3. Think of it like a box of crayons. A standard office monitor might be a box of 16 crayons, while a professional-grade IPS or OLED display is the big box of 96 crayons. If you are analyzing a security heat map, a wider color gamut helps you distinguish between subtle shades of red or orange that a cheaper monitor might just mash together into one solid block. The technician's summary. Resolution is the size of the workspace. Pixel density is the sharpness of the detail. Refresh rate is the smoothness of the motion. Color gamut is the richness of the palette. By mastering these 4 attributes, you'll be able to look at any spec sheet and know exactly how a monitor will perform before you ever plug it in.